The amount of Coca-Cola in a bottle can be modeled as a normal distribution with a standard deviation of 5 ml. The bottles with the bottom 35% of volume end at 480 ml. What is the mean on this model? As always, the first thing we need to do here is actually get to the part where you see the inverse normal distribution on your calculator. So we would go to Stat from the main menu like so. Distributions F5, click that. Normal F1, click that. Inverse normal F3, click that. Now you're on this screen. The next step, as always afterwards, is to now visualize the diagram and see what you're trying to find. We know that the lower bound, or the lower side of the data, ends at 480, and that area underneath it is 35%. So what we need to do here is pull up the graph and see that we're looking for something like this. We're looking for this red area. We know this red area is 0.35. We know that this line is ending at 480. We need to find what this mean number here is that's going to be in the center. And also we know the standard deviation is 5 ml. So we're trying to find what this mu is here, right? So what we're going to do is, again, we need to look at the standard normal distribution to find out what the z value should be, and then we'll work backwards and find the appropriate number. And we move this up as so. For a standard normal distribution, we know that the mean must be 0 and the standard deviation must be 1. Thankfully, when you open this, it's already set to that a lot of the time, unless you've been using it before, in which case you need to go back and change it. We know since it's the bottom 25%, bottom 35%, a lot of mistakes, it ends at 480 ml, so we know the tail must be to the left and the area underneath must be 0.35. So we click the area 0.35, and now we click execute. We get the z value of negative 0.3853204, which we have like so. This number being negative makes sense is because it's to the left of 0, which is the standard mean. Now we plug this number into this equation here. The z value is the z value we just found. X is the specific bound we've been given that is different from the mean. Mu would be the mean, in which case we don't know that in this equation, and we know the standard deviation is 5 for the setup. So I'm going to plug in those numbers. Negative 0.3853204 is 480, which is the bound, minus mu, which is the mean, over 5, which is the standard deviation. Now this 5 is dividing on this side, so I'm going to bring it over to the other side and multiply it. I'm going to end up with negative 0.3853204 times 5 is 480 minus mu. Simplify this to get negative 1.926602 on the bottom here. And afterwards, mu is then equal to 480 plus 1.926602. Because this negative 1.926602 is, it would go on the other side of the equals and become positive. And how the mu is on the other side here, I bring it over to the left side. It goes from minus mu to positive mu, and this negative number goes across the equal sign, goes from a negative number to a positive number. End up with 480 plus this number, which gives me 481 point da 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 da. I simplified this to one decimal place, or round it to one decimal place, sorry, to get 481.9 ml approximately. That gives me the final answer of the mean of this model is approximately 481.9 ml.